Thank you for joining us for another one of our high altitude balloon prep videos. This video was made by the Fort Hays State Makerspace. If you've been following along, by this point in the process, we've prepared our payloads and launched our balloons. But how are we going to track them? In this video, I'll show you the hardware and software used to track our high altitude balloons. The first piece of equipment I'm going to explain to you is our APRS radio. APRS stands for Automatic Packet Reporting System. This radio broadcasts a pulse at a set time period. We set ours for 2 minutes, and that pulse gives out the GPS location of the radio transmitter. The radio signal is received by a network of towers all over the world. One limitation of this system is that the signals can only travel by line of sight. So on the ground, typically you do not have reception. Our APRS radio is located here in our communications package. You can see the horizontal antenna. Inside, this waterproof container contains the radio transmitter. We use 3.7 volt batteries in it to provide a higher level of voltage. The signal from our radio transmitter is displayed online on web pages that we can access both from a laptop or our cell phones. Just look up aprs.fi and it will show you a live image of all active APRS radios worldwide. Using the search function, you can look at different parts of the world, different types of signals, signals that are stationary, signals that are moving, or you can type in the call sign of a signal and look for that transmitter particularly. The call signs of the two Fort Hays State HAB radios are K1AMO and N8VRN. Searching for one of our call signs will pull up a list of all the transmissions over the last several years. You can click on these different dates and see the track of each individual balloon on each day. Clicking on individual points on the track will give you the specific altitude and time of each individual transmission. With this information, we can take the data gathered by the LabQuest sensors and tie them to a specific point and time. We can also compare one balloon flight against another. Accessing this data live on our cell phones allows us to track the balloon in real time. Our second piece of tracking equipment is a Spot brand GPS tracker. It is located in the same communications payload box as the radio transmitter. The Spot tracker communicates with satellites rather than radio towers, so it will work in areas where the APRS has no reception. We can track the position of the Spot tracker in real time by logging into our account on the website. We can see this either on a laptop or on our mobile devices. Just as with the APRS, we can track the balloon live as it's flying. The Spot tracker broadcasts its GPS position every 2 minutes. We can follow along with our trackers as the balloon flies through the air. The two backup systems complement each other and help prevent a catastrophic failure where we might lose the payload. Once we see several GPS signals in the same location, we can assume that the balloon has landed. Remember, the APRS radio signal will not be received by the network at ground level. Using the GPS location, we can input that into Google Maps and then go directly to the landing location. GPS tracking has enabled us to find payloads in many difficult situations, such as in high weeds or crops. After retrieving the payloads, we go back to campus. Thank you for joining me for another video explaining the Fort Hays State University High Altitude Ballooning Program.